Now I have chosen question number 7 and then remaining we will do later. Seventh one, listen, most of the time the substitution given to the function within the power. So here I am choosing z as 1 plus x power 9. Immediate after choosing this, check the derivative appears in the, whether the derivative appears in the given problem. What is its derivative? dz by dx equal to 0 plus x power n, that is 9x power 8. Derivative of x power 9 is 9x power 8. X power n's derivative d by dx of x power n equal to n into x to the power n minus 1. So 9x power 9 minus 1 is 9x power 8. Here x power 8 presents. Now cross multiply dx, x power 8 into dx also presents. So you need not worry about it. Our substitution is correct. We can move for the dz equal to now dz equal to 9x power 8 dx and divide it dz by 9 equal to x power 8 into dx. We can go with the substitution, substituting all in one. 1 implies integral this 1 plus x power 9 into 5 whole power 5 is 1 plus x power z. So this is taken as totally z power 5 and this x power 8 dx will turn as dz by 9 and taking 1 by 9 as common, 1 by 9 constant out, 1 by 9 into integral z power 5 into dz. Now integrating we have 1 by 9 into z power 6 by 6 plus c. Substitute z equal to 1 plus x power 9 this. 1 by 9 into 1 plus x power 9 whole power 6 divided by 6 plus c will be the answer. It's a very simple thing. Z equal to 1 plus x power 9, differentiating 9x power 8. So finding dz 9x power 8 is equal to dx and x power 8 dx will be equal to dz by 9. Substituting in it, 1 plus x power 9 is taken as z. So while substituting this becomes z power 5. So z power 5. The remaining x power 8 into dx. The remaining are x power 8 into dx are remaining. So for that we have given substitution dz by 9. We found already. In substituting these two cases, the 1 by 9 is constant taken out. Then integral z power 5 dz. Integrating by x power n formula, x power n plus 1 by n plus 1. Z power 6 by 6 plus c. Substituting z equal to 1 plus x power 9. We will get the final answer is 1 by 9 into 1 plus x power 9 whole power 6 by 6 plus c. The question given question in terms of x, your answer will be also in terms of x. For that only we are again changing the z into, converting z into x. That's all. Now we have moved to question number 8. Comparatively this is very easy with the previous one. Here look at the problem. X power e plus e power x given. What is the derivative of x power e? It is also considered as x power n. Power n is constant. Here e is a constant, fixed constant value. Its derivative is e x power e minus 1. Like x power n formula, n x power n minus 1 here. N into x power n minus 1 like that. E into x power e minus 1, that's all. Look at the numerator, we have e minus 1 but e is not appeared there. Okay, when we move to e power x. But we cannot write it as x e power x minus 1 because in the power we have a function. Here we have a constant in the power. So the derivative of e power x is well known by us e power x only. Look at here we have e power x. Here e multiplied, here no e term. So simply taking e out, e power minus 1 as common. Taking e power minus 1 common, or we can go with some other way. Listen carefully here. So we can choose derivatives appears in the numerator. That is my point here. So put z equal to x power e plus e power x. Its derivative, some partially appears or wholly appears. It's not a problem to us. But we should have the terms such as some of the its derivative terms appear in the numerator right now. So such a functions are taken as are given substitution. So z equal to x power e plus e power x. Here differentiate dz by dx. X power e x power e minus 1. Okay, now here e power x means e power x only simply. Now remove e power x common to the terms. E as common. Remove e power 1, that is e as common from these two terms. Here e appears, here no e terms. Only e power x appears. So here taken out, remaining is x power e minus 1. Here no e term, that will be divided by e. And then bring it to the numerator, it will turn as e power x minus 1. So e into x power e minus 1 plus e power x minus 1 dz by dx. Now cross multiply it, we have dz equal to e into x power e minus 1 plus e power x minus 1 into dx. This dx cross multiplied. Now dz by e equal to x power e minus 1 plus e power x minus 1 into dx. That's all. Look at here. X power e minus 1 e power x minus 1 into dx in the numerator. We have derived those things as dz by e. So now substitution will take place in the question number 1. After substituting, finding this value, substitute in question number 1, the given question. Now take it as equation 1. 1 implies the numerator turn as dz by e. The denominator is z. That is equal to 1 by e into integral dz by z. Ez is a function, its derivative is the numerator dz. So we can go with the formula integral dx by x, or this is also written as 1 by x dx. Both are same only, dx by x or 1 by x dx. For both the functions we have integral log of modulus x plus c. Here dz by z we have, that is equal to 1 by e into log of modulus of z plus c. For modulus of z you can substitute the substituted value z equal to x power e power x, x power e plus e power x. So the final answer will be 1 by e log of modulus of z means x power e plus e power x plus c equal to x power e plus e power x. Just check it. The derivative of x power e is e x power e minus 1. So x power e minus 1 appears, and e power x is e power x. We have both terms its derivative. Suppose if you choose this one as function, what will happen? X power e minus 1 plus e power x minus 1. Derivative of x power e minus 1 is e minus 1 x to the power e minus 1 minus 1. The power will be e power minus 2. And we will have one multiplication of constant term e minus 1. So x power e minus 2 will not appear in the question. So you will leave those type of substitutions. You can check before entering it. Check if you do more problems in this type, easily you can understand which one is taken you first or which one given substitution in a sudden moment. That is that will happen when you get familiar in it. So repeatedly choose the problems and do it again. It may happen, definitely it will happen, because after doing repeated number of times you will get familiar definitely. And now we can move to next one. Question number 5 we are moving now. Question number 5 given as exercise 2.6. question number 5. 6x plus 7 by root of 3x square plus 7x minus 1 integral dx. Some different problems in the same type of format I will be given in 5 mark, but here it will be 2 mark or 3 mark only, because check out the denominator within the square root. 3x square plus 7x minus 7, and find its derivative. It is equal to 6x plus 7 appears in the numerator. So these type of cases I have given one formula to you. The first one is f dash of x by f of x dx into dx is equal to log of modulus of f of x plus c. And the second case related to this question is integral f dash of x divided by root of f of x dx will be equal to 2 times root of f of x plus c. So this is the related formula to the given question of 5 here. The function in the square root of the denominator and its derivative only in the numerator, we can go with this formula. Here f of x chosen as, put f of x is equal to rt dt, like that you can go, or directly you can go f of x 3x square plus 7x minus 1. The f dash of x implies 6x plus 7. 3 into x square become 2x, 7 into x become 1, minus 1 becomes 0, remaining is 6x plus 7, that is its derivative. Now substitute in 1 implies integral, the numerator is f dash of x into dx, the denominator is root of f of x. So you can choose this formula, that is equal to 2 times root of f of x, that is equal to 2 times root of f of x, equal to 2 times root of f of x plus c. Therefore substitute instead f of x is equal to x square plus 3x 3x square plus 7x minus 1, which will be equal to 2 into root of the function 3x square plus 7x minus 1 plus constant of integration c. This is the answer for this question. Question number 5. Given 4x plus 2 into root of x square plus x plus 1 is question number 6. Integrate it. Integral dx. 4x plus 2 into root of x square plus x plus 1 into dx. Here we have x, here we have x square. Derivative of x square is 2x, so it involves x. And then differentiating x with respect to 1, it is in the multiple of 2, 1 into 2 is 2, so here we have 1. The 1 becomes 0. When differentiating, we have 2 terms here that appear here, so we can go with x square plus 1, x plus 1 as a substitution term. Put z equal to x square plus x plus 1. Differentiating, dz by dx is equal to 2x plus 1. Here differentiation takes place. Dz by dx is 2x plus 1. Dz equal to 2x plus 1 into dx. Now this is given as a root of z. When substitution, it will turn as root of z. Here we have 4x plus 2 into dx, but in our dz term, we have only 2x plus 1 into dx. Look at here, multiply it by 2, 4x plus 2. We can get the remaining term. So here multiply it by 2, or so multiply it by 2, or you can simplify this question. So 1 implies, take 1 implies It is better to multiply, or you can go in this way. 1 implies integral, taking 2 as common, 2 into 2x plus 1 into root of x square plus x plus 1 into dx. Now, which is equal to 2 into integral this 2x plus 1 into dx are taken as dz, and then root of x square plus x plus 1 is given as root of z. Now root of z is z power half, 2 into integral z power half into dz. This is in the form of integral x power n. So 2 into, you can go with the formula of x power n plus 1 by n plus 1. Z power 1 by 2 plus 1 by 1 by 2 plus 1 plus c, which is equal to 2 into z power 3 by 2 divided by 3 by 2 plus c. And here this 2 by 3 is multiplied as 3 by 2 is multiplied with the 2 as 2 by 3. So which is equal to 2 by 3 into 2 into z power 3 by 2 plus c. So 4 by 3 into, instead z we have substituted x square plus x plus 1. So x square plus x plus 1 whole power 3 by 2 plus constant of integration c. 4 by 3 x square plus x plus 1 plus 1 whole power 3 by 2 plus c is the answer of question number 6. Question number 9, 1 by x log x. 1 by x log x is given, which is equal to 1 by x into 1 by log x. The derivative of log x is 1 by x, isn't it? The derivative of log x is 1 by x. We are sure derivative of log x is 1 by x. So we can give substitution for log x because its derivative is 1 by x. So integral dx equal to integral dx here. Now put z equal to log x and differentiate dz by dx is equal to 1 by x and dz equal to 1 by x into dx. dz equal to 1 by x into dx. Look at here. This 1 by x and dx are taken as dz. The remaining is 1 by log x, that is 1 by log x is z. So 1 implies integral 1 by x dx is dz, so dz. The remaining is 1 by z. Now we have formula integral 1 by x dx equal to log of modulus of x plus c. So moving with that formula, this will be equal to log of modulus of z plus c. So question in the terms of x, the answer should be in the terms of x. So substituting again log x for z here, log of modulus of log x plus c. That's all. Very easy this one. Just split it, then choose z, apply it easily, you can get it. Question number 11, e power x into 1 plus x into log of x e power x. Till this time we have completed 9 problems and the 10th one we will do at the last. Now the question number 11. There are 9 questions completed. Here 11th question, 10th one we will keep it in the last. So e power x into 1 plus x into log of x e power x. This is also a very simple thing. Just a small substitution here. E power x into 1 plus x. Multiply inside e power x plus x e power x. Here, what is the derivative of this one? E power x plus 1 into e power x plus x into e power x. But here we have x e power x only. The terms are in product. Here the terms are in addition. So we cannot take this one as a function. So keep x e power x as a function. Suppose if we choose x e power x as a function, check its derivative. X e power x. Derivative of x e power x by the product rule uv, u dash v plus u v dash. So u dash means 1. It takes place, differentiation takes place with respect to x. So 1 into e power x plus u remains, and v dash means e power x. Remove e power x as common, 1 plus x. We have this term here, e power x into 1 plus x. So it is better to substitute u equal to x e power x. Substitute here, put z equal to, so integral dx, and put z equal to x e power x. What is its derivative? dz by dx is equal to differentiation with respect to x, 1 into e power x plus x into e power x, u dash 1 v plus u into v dash e power x is e power x. So e power x is taken out, 1 plus x within the bracket. So dz equal to e power x into 1 plus x into dx. Now look at the question. Let it be 1. Now 1 implies integral. The terms e power x, 1 plus x and dx all taken as dz. So write here dz. The remaining is log x power ex. Log of x into e power x. So log of, given substitution to x e power x only, that is z. So log z dz. Log z dz. Here, if you know the formula, directly you can substitute. Else, you should apply integration by parts method. In this case, this is taken as integral u dv, and u equal to log z, and remaining are integral dv equal to integral dz. So v equal to z, log x dz, log z dz equal to integral u dv in the form of u dv. So this log z is taken as u, the remaining term integral dz is integral dv. From this integral dv we can derive v, and integral dz is as z. By use of the integration by parts formula, integral u dv equal to uv minus integral v du. We need the value of du here. U and v are we have derived already, and then we need du to complete the problem. So differentiate this one. Du by dz equal to 1 by z, which implies du equal to 1 by z dz. Now we can apply in this formula integral u dv equal to uv minus integral v du. Apply. When we apply, which is equal to, that is take it as 2. 2 implies integral log z dz equal to uv, product of u and v. U is log z, v is z. So z log z minus integral v du, v is z, and du means 1 by z dz. Now cancelling these two, we have integral dz only. So z log z minus integral dz plus minus integral dz. Now integrate this dz, that will become z. So z log z minus z plus c. Now the question is u equal to log z is taken. So z log z minus z plus c. In the question we have taken z as x e power x. So substituting here x e power x log of, or take z as common, you can substitute x e power x minus x e power x plus c will be the final answer. By substituting z equal to x e power x, we will get x e power x log of x e power x minus x e power x plus c is the answer. 13th question, integral e power x into 1 by x square minus 2 by x cube into dx. It is in some particular form. I have written the right side e power x f of x plus f dash of x dx form. Check here, check the formula e power x, and then here is the function f of x. F of x is equal to 1 by x square. What is the derivative? F dash of x. F dash of x means derivative of, f of x is 1 by x square. It can change it as x power minus 2. What is the derivative? X power n formula minus 2x power minus 2 minus 1. N x power n minus 1 formula. Simplifying this, we have minus 2x power minus 3, and which is equal to minus 2 by x power 3, minus 2 by x power plus 3, minus 2 by x power plus 3 here. So look at the second term within the bracket, that is f dash of x. So this is f of x and another one is f dash of x. So f dash of x plus f of x plus f dash of x into e power x, it will follow this formula. So to take f of x first and then write f dash of x, then go with the formula of integral e power x into f of x plus f dash of x dx. Put f of x is equal to 1 by x square and f dash of x is equal to minus 2 by x cube, which implies 1 implies integral e power x into f of x plus f dash of x into dx. So that is equal to e power x into f of x plus c, which will be equal to e power x into f of x means 1 by x square plus c. Is the final answer of integral e power x into 1 minus x square minus 2 by x cube into dx.